Hello everyone, and today we are solving another problem with 3D printing, or using 3D printing. So the problem today is that there's a little segment that I'd like to try on my YouTube channel for like a short or something, and for that I want a reporter style microphone that you hold and whatever. It's just something stupid and little, but I don't have it and I don't want to buy it. So what I'm going to use is what I already have. I have this wireless lavalier microphone, kind of bulky for a lavalier microphone, but it can hopefully get the job done, and also since it is a little more bulky, it should hopefully make it a little bit easier for our modeling purposes here. So what we're going to do is we're going to make basically a handle for this thing, and we're just going to have the microphone module on the handle. So let's see if I can even do that, because I only have a basic idea of how I want to try and do this, but I don't have any concrete plans. So to get started, start on the bottom here. Gotta start, and we also gotta start by making parameters, of course. We need the width and length of this thing. Okay, so this thing is a complex body with lots of little bits on it. So what I'm thinking is I want to put brackets on the corners of this, and then hopefully on the back make it available for this clip to actually clip onto the thing to help secure it a little bit more. But the problem with that is that there are little bumps here on the back there, so that's going to be just another slight complication that I have to contend with. And so for what the hell would this even be? Let's say width of it. No, I'm looking at it like this. So if we're looking at the width, we're going to go here, which is about, it says that it's a little bigger than 14.5, so we'll do, first things first is fit tolerance, which for my machine, my Bambulas P1P is usually 0.2. Then we will do I guess that would be the length, which will be 14.7 plus fit tolerance, takes it to roughly 15. And now this, it's going to be a bit difficult, but for now, I think we're just going to go with the total width, measuring the whole thing. There's not very complex on the sides other than these buttons, which we will try to keep showing, but we will have to wait on that for a second here. Get in between the buttons. And we got 41.8 plus fit tolerance. What's next? That would be the mic width. Let's make the box. So we can do a simple rectangle like so. So that would be length, and this would be width. Boom, that's the size of our inner area where we want to hold the microphone. Now we want to probably decide a wall thickness, which we don't want super thick, but we don't want super thin either. But thin shouldn't be too much of a bad thing. I'm going to try and do some estimations here on the back, see how this looks. That's about 5.3 millimeters, a gap from there, but not really showing how much is actually in there. It's really hard to tell. Looks like it might be a 2 millimeter gap. So what I'm thinking is make another parameter, wall thickness, and we'll do 4 millimeters. And then we will do the clip wall thickness, and that will be 2 millimeters. Let's make something like this. And that was really crappily drawn. Let's fix that. We're going to parameter all of these to be the wall thickness. Let's get more parameters because there's lots of little details about this thing. So we need the clip width, the total clip on the back here, which is 18.2 by the seams of it. Can't put that in there, it's not the right thing. 18.2, and we'll do plus fit tolerance, but we'll multiply the fit tolerance by 2. So we'll put that in parentheses to make sure that it gets properly multiplied and doesn't affect the equation and all that. Tolerance times 2, and then that is back clip width. And then we also will need clip wall height for it to grab onto it, for it to know how high it needs to be to grab onto it, yet not also impede and get stuck on the actual hinge of the clip, of course. Now that's a good question right there. So we want it a little bit smaller than what that is. What is this? 21.7, let's do 21.5. The smaller the better. Though we don't want it too small, of course, as well. So 21.5, we don't need fit tolerance on that. Let's make a line just right here, doesn't matter. Oh my god, except for it could just not be utterly atrocious, that'd be great. And then right here we want the clip wall thickness. We need the clip wall width on the corners here. And then we want the center point, which we don't have on there. Let's make a line at the center there, put it just directly down, make it a construction line for reference. Then from that point, we can measure from there to the side, and this would be some mic width divided by 2. Make sure that's centered. Hopefully this thing is also centered. It looks centered. So then let's do something like this. We need to connect those. So then from here to here, we can do the wall thickness. That's all connected now. And then we can mirror these over to the other side, over this line. Okay, and then we should hopefully be able to connect that. Yep, and we have one solid piece. Problem, we don't want this to be a solid thing yet. So we're gonna turn all these regular lines into construction lines for now. Except for maybe that one. That one probably can stay. Because we want this back wall solid. Because that has no buttons or anything. We want the face to be showing so that we could see the icons. I'm not so worried about the label, but I would like to be able to see the icons just in case. It'd be nice to be able to keep the charging port, doesn't matter, but the headphone monitoring would be nice, though it's not super great on this unit. There's not a good volume control. And then of course there are the buttons on the side, which has the power, it affects the volume, all sorts of controls. We don't want those to get knocked around in there, so we want to keep these open so that we can also press them if we want to, hopefully. So, the problem with that is we need it to get the width of these buttons. So I'm going to try and just lightly measure these, try and get just the right amount of pressure to get these in between the calipers, the little bit of ledge that they have. It seems like it's 4.2. Yeah. So, change parameters. Make a new one. Button control width. And it was 4.2, right? Yeah. And then we will also add fit tolerance to that, just to be sure. So then we need a center point along this line, right here. Make that a construction line. We need to make a line here, here. Make a little box here. Crap. Okay. Made a mistake there. That's why we need to do this. Button width. Okay. So then we need a center line in here. Okay, so we don't need this one, actually. Can delete that. This center line will be a construction line as well. To center that, we will do our typical method of just doing something like this. I believe that'd be the depth, wouldn't it? What did I call it? Length divided by 2. That does not seem right. I know why it doesn't seem right. The reason that wasn't right is because we measured from the outer side. We need to measure it from the inner side. Length divided by 2. Okay, so there's our little gap right there. These side lines here, those can be construction lines as well, because we don't want those to be solid anyway. We want that to be an open area. Meanwhile, we do want this to be closed. And the headphone jack is offset a bit, unfortunately. These buttons do look centered, hopefully. I do want to add a bit more fit tolerance into that. I just don't know how much. I'm thinking maybe just a full millimeter of fit tolerance. So if it's 0.2, we would need to times it by 5, I believe, right? 2, 4, 6, 8, 5, or 10. 2, 4, 6, 8, 10. Yeah, okay. That will give us a full millimeter of fit tolerance, which a millimeter is not huge, but we also don't have a lot of space to work with. It's only got a little bit of gripping area, so we just gotta be real careful with this. I'm really debating whether or not I should even worry about this headphone jack. I don't think it's gonna be worth the hassle of trying to do it. I think that maybe I should just enclose that side. Because it would be nice to have, but... Okay, well, a solution is that I could make a circle in that area instead of making a whole slit, since the buttons, if I'm planning to slide this in from the top of this is looking at it from the top down, like as if you're looking at it from, look, it's gonna go around here like this. So when you slide it in, you don't want it hitting the buttons. So that's why there needs to be a slit for the buttons. However, for this slot, this jack, you just need to have it wide enough to be able to accommodate the jack and whatever you plug into it. It needs to be big enough for the headphones or whatever you're monitoring with, or that male jack to be able to fit around there or fit in there. So I think that's what I'm gonna go with. Let's we make those solid lines again. Now the front here, that's a different story, because like I said, you can't see it now unless you've seen the review. There's these little symbols here. Sorry, I bumped my head into it. There's little symbols here, here, and then 3 across there. There are little lights that'll turn on that are indicators of if something is on or not. I want to see those. But I also measured this depth. I think I may have done this a bit wrong. I think that this probably needed to be the solid side, and this needed to be the depth. Thinking about multiple things now, and it's not great. So first things first, let's measure the width of the face of this thing, the part that is accidented, because it's just accidented and sticking out just like the littlest bit, and it's basically 30 millimeters. 30 millimeters plus fit tolerance, just in case. It's equals fit tolerance. They don't like when you do that. Next, mic face width. Okay, mic face width. Let's do this. Mic face width. There is that. We need the center of this thing here, but it's gonna be difficult. I guess what I can do is I just do this. What the hell? Why is it not going straight? Construction line first of all. Then we'll do it like this. It's at an angle. God damn it. Fuck. Okay. Make face width divided by 2. There's that. Then this by this. Mic width divided by 2. There's that. So then that'll give us that much of an area. Now this looks like it might be like fairly substantial, but in my experience it can definitely be deceiving. Now these lines need to be construction lines. Meanwhile the other lines need to not be construction lines. So we're gonna do something like this. Now that's a solid area, and we have this. Okay, so now we have the face carved out. Now, the other thing that I was thinking about earlier was that I think I did this wrong because I need to have an indent for these little spokes to get around. It's really hard to tell how thick they are. I'll try and estimate it by eyeballing it here. I estimated 2 millimeters. They look like they may be smaller, but I'm trying to put the least amount of stress on the actual clip so that it doesn't break or anything. What does 2 millimeters look like? Yeah, that's bigger. Let's do 1.5 on that. First of all, so where is it? Clip wall thickness is 1.5. And on top of that, it unfortunately needs to be inverted how this works. The clip needs to be on the inside, not the outside. So, this is gonna be a little annoying to switch up. Basically have to delete the whole thing there. Let's delete this. I have to remember how I did it now. So then this should be proper. Hopefully it can print this wall properly. I don't know if I can print a wall that thin, but we're gonna try. Hopefully the clip won't break this or anything. But we're also going to have to mirror this again. But actually we didn't put a middle point on this like we should have. Bam. Okay. So I think we have the basic idea of what needs to be done here. And what we can do is we can also print out test prints first, test these little bits and see if it'll actually work. Hopefully this shouldn't take up a lot of filament either. Okay, we're gonna finish the sketch. Oh crap. Alright, so going back into the sketch, let's make the outer lines solid. Because I do want to make the bottom here. So we need to select all these bits. We'll do negative wall thickness. Bring the sketch back. Then we will extrude these parts here. And then we will need a new parameter before we can do that, of course. And we want this to come basically all the way up to the top here, so that should hopefully be an easy measurement. Just measuring from the top to the bottom, which my calipers are angled weird. They're not flat, which is really freaking stupid, I think. So it's 46.2. We shouldn't need a fit tolerance for that. This is mic height. Did I spell that right? I think it did. I've been having an issue with height lately, the word height, and I think I keep misspelling it. As long as I get the job done, I guess. Okay, bam. So now let's save. So that is only the basic idea right there. We can make it look a little bit better, hopefully. Let's try and angle it in a bit. Wall thickness divided by 2, divided by 1.5. And then we're gonna copy and paste that. Well, actually, yeah, we'll copy it, delete it, put in a 0, because I want to select more edges. Then we'll paste it back in. There's that. I want to round off these corners a bit, although I don't know if I'm going to be able to now. Okay, let's go back here, and we will do it just by... We'll do it by 2. On the inner rounding, this is going to be to protect the microphone and such. We're going to round off these inner corners to hopefully prevent any scratches or anything on the microphone. All thickness divided by 2. What does 3 look like? Might be a bit better. Yeah, I think that's better. Okay. You can also hopefully angle the top edges here, just for the aesthetic. Okay, there's that. Though it would be a good idea to angle inwards a bit on here for inserting the microphone. Maybe rounding it would be better. Little better for keeping the aesthetic as well. Because obviously a part of this has to be visual as well. So I might as well make it look good as well. Well, thickness divided by 2, which isn't going to work because it doesn't like that little bit right there. So what if you unselected it? Nope, that wouldn't work. It doesn't like something else now. Where? Probably should reduce it anyway. Fug. Well, 1.5 is going to make it bigger, isn't it? So divided by 2, which is not going to work. 3 still doesn't work. So can I angle it again? What if I angle it just at a lower number? Because there's all these polygons, so hopefully they should all connect together. Alright, let's just type in numbers. 1 works. 2 does not work. We only want it to be a small number anyway, so there's 1. What about 0.5? Might be a little small. 75. Okay. This is a bit of a complex geometry, but that's okay. I think this should be good to test. So we're going to start printing out this piece right here. Why is this untitled, by the way? Now we got the actual name here. Now let's save again. Okay, so we have it saved. Now we got to export it. Okay, import this thing. And it brings this up. I don't know. I've never worried about these settings. I always just do the default. There's that. How will it work? How does it look sliced normally? This wall does get created. Okay, cool. Hopefully it's not too thick. Hopefully it's not too thin. And that's why the first thing I actually want to do before printing this whole thing is I actually want to slice it. Slice this model and I mean, you know, cut it actually, not actually slice it. Rotation on the x-axis, 90 degrees. Pull it back here. We want position 0. Okay. Well, yeah, let's perform the cut. Unselect this. Delete this one. Okay, so there's the model right there. Hopefully it won't get knocked over. It is pretty thin. Was printing something like this, it'd probably be a better idea to print it flat, but I would like to print it in the same orientation that it would actually be printing normally, just in case of any unforeseen consequences. This wall is 4 millimeters thick, though. This is why we're testing it. Okay. Because what I was thinking is that maybe I have to actually cut out a bit from this side as well to make it optimal for having this thing sit straight in there and clip onto it. It's possible that the 4 millimeter total thing is going to be too big, especially if there are also clips on the inside of the actual clip itself, not just on the body. So I'm going to print this out, and I'm going to test it either way. We're going to be printing out of black Polymaker PLA, Polylite PLA, and yeah, we're going to see how this goes. Slice it. Is there any infill? A bit. I want it to be a little bit durable, so we'll leave it at 10%. We have 3D honeycomb so that the infill doesn't overlap itself and cause issues on a much taller print, which obviously this shouldn't be very tall, but oh well. I just had a realization. I don't know how I'm going to get the handle on this thing. Okay. There are 2 options that I can think of. 3, actually. First option, which is the simplest, is friction fit. It is the simplest because it is just that you make a cavity in the bottom and then you put the actual handle part, shove it in there, and then with the tension of them sitting together, they stick together, hopefully. That one is difficult because you have to know your machine well enough that it's going to actually, you know, stick together and that they can actually fit together without being too loose or too tight. It has to be pretty precision. Other solution, next one, is the next simplest, is gluing it. So it's basically the same thing as the friction fit, but you have a little bit looser tolerance so that you make sure that the handle can fit onto the head there, and then it gets adhered with adhesive. And then the final one that I thought about earlier before while trying to plan this out a bit was threads. Creating threads in Fusion 360 isn't hard, but creating exaggerated threads that are very big, especially for 3D printing, it's a little more difficult. I have not been able to make good 3D printing threads very much in my experience, So yeah, that's gonna be a bit difficult. Now obviously this is only a test print, but it's gonna need a thicker base. But also I didn't do anything to the base of it yet, so we'll worry about that in a bit. First things first is we gotta test this clip, see if it'll work. I gotta go change the filament in my printer because I have white in there right now. I want it to be black, and then I'll be back hopefully in a bit and show you how it works. Okay, so I have printed the test thing here and it did not go well because there's some stuff that I forgot, of course. The first issue is, of course, that there is the issue that I need to take into consideration the back nubs. It's pushing the whole thing forward and it's creating a problem. Another thing is that I think I even thought about it before because there is the clip wall height. I completely disregarded that, unfortunately. I forgot it. So this wall needs to not be the same height, it needs to be much lower because of where it sits on the actual microphone. So those are the two things we need to figure out. So the first thing that we should do is let's change the extrusion. We need to take, oh, that is not good. Was that that's tilted? Doesn't look like it on here, but that is, that's unfortunate. Let's change that, fix that back up. So now that we have that, we need to add 2 hard lines, not construction lines there, to separate that so that when we go back to this extrusion here, which is also going to mess up something else. It's the wrong extrusion actually. Go to this extrusion, we'll do this one differently. Which, yeah, it's going to change the, yeah, that. So we need another extrusion to bring this up to the clip height. Much lower. There we go. Hopefully that's actually correct. So then I just want to round this off, and we're going to do it by the clip wall thickness divided by 2, because then I'll perfectly round it off. Okay, so there's that. That's completed. The next thing that we have to do is figure out how we're actually going to indent that these clips. An option is to actually put a hole where the dots would actually be, though that is going to cause an issue with extrusion here, or not, it's going to cause an issue with printing. Let's make a sketch here. We're going to create a projection of this line right here. Okay, so then from here let's make a line. We'll also we'll project this one just for the sake of having it. Make 2 lines here, make them construction lines. These are just for reference. Do this, we want these at 45-degree angles. That's not going the way I want it to, because it probably just needed to go straight. It's already at 45, but I want to lock it in. Now I'm not, the reason I'm doing it this way, I'm going to try and just do a general cutout here, because I don't want to take the, I don't want to put the effort in to figure out where these things actually are in relation to how everything's going to work. So that can actually be an issue. Does that mean this thing's going to rattle around in there? I guess it depends on how tight the extrusion the other parts actually are. Plus this clip is like perfectly inset in there. I think that this way is going to work and it's going to be more versatile. Okay, from the bottom of the thing, so it needs to be at least, by the looks of it, 15 millimeters high. So let's get a line here. Let's make it a construction line for now. Okay. Let's see, that would not have worked. But also this is bad for our thing here. Can we move it up? Why is it not allowing me to do that? Because see, these extrusions need to come off of there. But I could probably do a little bit of a bridge up top, especially that's not going to make too much of a difference. Let's delete these lines. Then from here, 45 degrees, here, 45. Sir. Maybe it can just be 0? I don't know what the fuck it's doing. God damn it. Why does it keep doing this shit to me? Okay, so that's a pretty tiny gap, so that's not going to be too bad of it. That's not going to be too bad in general. So then, how long are the spikes? Like, how far do they go? I assume that they're symmetrical, so I'm just going to measure the bottom ones because the top ones are difficult. Actually, I could do it. Hang on. Maybe not. Okay. Going with the bottom ones. Looks like it's only 3.5 meters, a little bit longer. So just to be safe, we'll make it 4. Make another line. 4 millimeters away. Okay, so then logically, this should be roughly where the things are gonna go. So let's make it actually like 2 millimeters bigger, just to be safe. So then actually, we should be able to just extrude and cut out this shape right here. Finish sketch. Extrude. It needs to be negative, and then that would be the thickness. It would be the clip wall thickness. Cut through that, and we have a hole there. The reason why we need these 45-degree angles is because when the printer is building up, it needs to actually be able to build up and not have this overhang sag. At least, you know, preferably we wouldn't have that. I would like this to be a little bit bigger though. Like, I would like the gap to be farther down, but then that makes the gap a little bit bigger for what it has to print, and then it, you know, the farther down it gets, the worse quality it's gonna be, and it's gonna mess up the print. But it's also on the back, so it doesn't matter as much, and the clip should make it over that. So I'm gonna do an executive decision and change that, because yeah, 1 millimeter is really small for those that don't know. I'd like 4. That's not gonna be good. That's 2 look. It's a little better. 2 millimeters is at least a respectable thickness for the most part. And maybe not, it's still pretty small. For reference, what's this gap? It's longer than 2 millimeters, so that's kind of have a reference of how far my printer can bridge, but not exactly for sure. So right now that's 3 millimeters across, because 3 millimeters, I think it can do that. What do I think is the maximum it can't do? 5 millimeters is kind of starting to put, it's not pushing it, but I think around 7 to 8 millimeters is when it starts to properly sag. So let's actually see what 4 millimeters is, how far that's apart. It looks pretty far. 7 millimeters, okay. How about 5 millimeters? I'll take it. I'll try that one. We'll see how that goes. Looks a little bit more sturdy now. Okay, cool. I guess let's save this, and then we'll slice it, get this back part off, and we'll see how that one goes. Okay, so here's the new model. Let's just slice this as it is. Just take a look at this. So yeah, it says that that's a, you know, pretty crazy overhang, and it's gonna be worrying. Another thing that we could do is, I think that in this situation, some tree supports would be perfect. It'd be a little more plastic, but I think that's probably okay, especially if this works better. But at the same time, that means I could also lower this even more and make it a little even better. But we'll print this and see how it goes with how it is. But first, you know, strength, we need, is at the bottom. What? Oh, support is its own tab. Right. I don't use supports very much because I try and avoid them at all costs, but I'm thinking about it here, you know? Slice it. It says it's got tree auto. It says it has support enabled already, but it's not doing support. Honestly, I don't know why this isn't working. Is it because it's small overhang? It is. Okay, so it's small enough where it thinks that it may not be an issue. So I guess, yeah, we'll cut this up and see if that will work then. Okay, there's the cut. It's not as good as it was last time, but, you know, oh well. Hopefully it'll slice it out. It didn't exactly, but that's alright. Alright, let's print this out and see what happens. Okay, so I have the next test print right here, and there is a small problem. So it is pretty close, and both of the bumps all fit in that little cavity we made. However, the clip is still held upward because this wall needs to be set inside. If I flip this on the other side of the test, it sits in there fairly well. So as far as I can tell, we basically just need to shift this wall to the other side like it originally was, and then from there we should be good. I'm gonna do another test print to make sure that the wall situation does work and there's not any other unforeseen issues. And I also want to test it with the bottom on and maybe with the corner walls to make sure that this whole fit tolerance is actually better. So let's get started on that. We need sketch 1, I believe, and we have to once again delete all of this. Connect those up. All right, so now we have this back in place. Things are breaking. So what was this? Why is this breaking? So then there's this corner that gets rounded, but why is anything affected here? Like, oh, it's because I needed to round these ones. Okay. Control C that. Change this to 0. Let me just go with that. Paste it back in. Next to that. Now the next one. The angling is off. Why? Oh my god, why is this such a pain in the ass? It's wall thickness divided by 2. Okay, so I could do that. But do I even want to? Maybe. And now it says it won't work because of the rounding. That's really fucking stupid, and I don't know why it's doing that. It's not even that complicated, I don't think. It just needs to angle in and then round. Now that I think about it, we should also round these outside corners. But I guess I need to worry about that after. Let's just do this for now. Let's do another chamfer on here. This is not gonna work. What the fuck's wrong with you? Cannot be created at the requested size. Try adjusting the size. Why don't you fuck off? You ever consider that one? It seems so simple, yet of course it's not. Well, here's the main reason, is because this is a different height again. Go back in the sketch. Forgot these freaking lines, of course. And now it has a conniption with everything. We need an extrusion here, though I think we had the extrusion. There's that one, but we need this one. Clip wall height. Yeah, we still need that, but it needs to be on the inside now? Because yeah, that's the outside, so it needs to be on the inside, because the inside fit better. So then this extrusion, can I change where the, you know what, we don't even have to, what we can do is we will do, instead of distance, we'll do to object, to here, then it'll just cut all the way through. Solve that problem. Now this, there was this problem, and now we should hopefully be able to do this, if it's not going to be a bitch about it. But it is! So cool. Alright, just do not freaking chain select. Yeah, that's what I freaking thought. I don't know, it's not perfect, but it's fine. I'll take it. It's because I should do this before the rounding. But it worked over there, so I don't know why it's not working here. Look at this complex little bit right there. It could solve this, but it can't solve this one curve. And this, I believe, was the rounding for on the top of here. What the fuck? Oh, was the inner chamfering here? So it's 0.75, and we need to add on these. 5. It still works, thank God. Okay, now this red one, this one's definitely the one, because it has no idea what to do. Because the geometry it was on, it no longer exists at all, instead of having any reference point. Are you f***ing stupid? What? Oh my god, what is it doing? Clip wall thickness. Did that just flatten it? Yeah, we need to divide that by 2, I believe. Yeah, it solves that impossible thing, but nope, can't do this, can't do the curve, can't do it. So infuriating. Why are things missing now? The sketch is having problems, I guess? Why is it grayed out? Okay, there we go. This is still having problems because the geometry it was referencing is no longer there. We're not gonna worry about it though, because it's still, made temporary and it's all should be the same. It's just slightly on a different position, whatever. Okay, that should be what we need to do. I just have to figure out how I want to freaking make a test thing of this. First of all, let's save. Then we want to take this one. Once it uploads, okay, never mind. Copy it to the same place, hopefully. We're gonna make this one read-only for now. We're gonna change this one to editable. I'm gonna rename it test, even though we're not gonna be able to see that. I don't think you can even extend this out. It's not giving me an option to, like, you know, click and drag it to make it longer, which is really annoying. I wish the name would wrap around or something so you can actually read the full thing, because I don't know how you're supposed to have any decent name here with this many. I mean, for simple projects, yes, you can get a simple name, but when you're trying to, you know, describe what the hell the project actually is, when you have lots of different projects, you can't see what the f***'s happening. Anyway, there's also a different way to, like, list these, but then I don't like it, if I remember correctly. So here's what I'm actually gonna do. All I want to do, I need to open this one first of all. I'm gonna go into the original sketch here. I'm gonna make lines right here. Actually, that might be the only line that I would need and want. Finish sketch. And we're gonna go to the original extrusion, which is gonna fuck things up probably. Need this one. We're gonna remove that one because I want the bottom so that I know how tall and where it actually properly sits in this whole assembly, and then I want to make sure that it can fit in between these walls, and I want to see if the buttons are going to sit properly in that slot. So then we click OK on that, and it surprisingly didn't break much. So it's got like light warnings, but there's no serious warnings, so we're not gonna worry about fixing those, especially for the test model. We're gonna save, and then we'll export this. I'm trying to think about, I don't have to think about it yet. I was gonna say I'm trying to think about how the slot is going to work for putting the handle on, but I'm not gonna concern myself with it right now. This is why I always forget things, why I forgot that I needed to lower this wall, because I started worrying about a million other things, trying to think of every possible issue that could happen, and then I forgot some. Another thing I forgot to mention is that since this was so thin, I was worried about, you know, its adhesion, so I actually used my half speed settings for both of those previous test prints, but this one that we're going to print I think should be fine on full speed, since it's got enough of a base that it should be steady. It might result in slightly worse print quality, but you know, the P1P is usually decent. I'm trying to make sure I upkeep on the maintenance, but it's hard for me to tell how much maintenance I actually need because I don't use my printer as frequently as other people. Plus it's just annoying to do. Okay, so there's the model. Should be good to just slice it and have it go, because also another thing I forgot to look at was how well this arch turned out, and it turned out it's not perfect, but it's pretty close. There's only the tiniest little drooping right here, which could be easily fixed by a tree support, but I'm not going to worry about it. It's literally so minuscule that it does not matter. So I'm going to send this to the printer, and we'll see how this works. Okay, so we have the next test model, and as you can see, did not exactly go perfect. So there are two major problems with this model the way it is now. First problem is that when you introduce the fit, the fit of the microphone is fairly perfect actually, so that's a good thing. However, because there's no wiggle room inside of the slot, the bumps on the back that are actually attached to the back of the microphone, they get impeded and they stop the microphone from coming all the way down on the bar. So the bar does actually have to be lifted, and it has to be thinner, I believe, based on some of these other examples and such. Another issue was that the first time, the wrong model somehow got exported when I'd made the test model. So the lip wasn't even on the inside like it was supposed to. It was on the outside again, which in the outside model, it can insert into the thing. I don't know if I said this, hopefully it gets cut out if I didn't. There's a little bit of flexing on the clip, so we don't want that. So yeah, we need to, it's really difficult to try and make this exactly the way it needs to be, especially for my model. So we need to lift it off by I need to find the exact size of these things, but it's really hard to measure it. I can't do it. Where do my calipers go? I need to measure these, but it's just too difficult to get in there to try and figure it out. I just have to estimate it, and it is not going well. Before I worry about that, the next issue is that somehow I managed to model the slots backwards. So I guess I might have been looking at it like I don't know how I messed this up, but when you put this in, the buttons are on this side, not this side. So we need to flip that over, which is going to be a small pain in the butt, but it's going to take a little bit of time. That's going to be really annoying, but let's get to the actual modeling here. So off camera, just like a couple seconds before I started this recording, I added these construction lines so that I can just quickly move over these other lines. Okay, so we have this slot now, so now we can delete this area, these lines right there, because those are no longer necessary. However, why is this open? Because this line needs to be a construction line. And then we need to connect these lines, like so. That's why it's open, which also means we need to connect these lines. Finish that. Now the sketch is going to be all kinds of whack, or the extrusion, I mean. That should be it. And it looks like it actually kind of replaced itself fairly well, so that's good to see. Nice to see. These obviously need to be fixed, but I don't remember how I did it, honestly. Go through the steps again. I forget this every time. Okay, so this is the one we have to adjust. This is wall thickness divided by 2, but we can copy that. Put in 0, and let's try and get these. Hopefully it actually works. Okay, it does. Cool. And then we should be able to fast forward to the end point, and it should be okay, I think. Except now we actually have to adjust this, figure that situation out. So we have to go back to the original sketch, and this is gonna break up a bunch of things. So we need to make a parameter for clip bump, let's just say clearance. Is it spelled with an A? Oh, whatever, I get the idea. It's so dark. To me, it was looking like it was going to be like a millimeter tall, which I have a ½ millimeter extra. That can make a big difference. We're working with this type of with these angles and such. Okay, what we're going to do is we're going to do 1.2, which is just a little less than what it had already. Maybe? Actually, how long is that? 2.5, so it's going to be a lot less, actually. So we need to delete this and delete all of this. Line, parameter it, back clip width, line in the center, just do roughly that, who cares. Like width divided by 2. Then from here, on that axis, we need clip bump clearance. That it just fucking upped. God, I hate sometimes I just hate this program so unbelievably much. I have to put a parameter here to make sure that the size stays proper. Nope, it's over constrained, yet it did something really freaking stupid before. Oh, it's because this one's constrained and then it also has the constraint made by this construction line now. Okay, so now the bump clearance should work. There you go. So then we do something like this. Okay, so there's the bump clearance. Now we need to make another line here. Make it horizontal, make sure that's the right, stays in place, these construction lines. But actually these need to not be construction lines, those need to be solid, I think. Because that needs to be the bar right there. Because then in between here, we need the thickness. Clip wall thickness, which 1.5 is seeming like it's going to be too much, so we'll try a millimeter. Is this working? What is happening? Is it just fucking locking up for no reason? Did I get this centered? Let's get another construction line just to make sure. It is not exactly right. How the hell did that happen? Can't make this horizontal because it would be over constrained. So why is this not centered? The width is constrained and it's coming from both of the corners. So how can it be messed up? It just doesn't even make sense. This is supposedly on the midpoint. What the f do you mean? Are you stupid? God, I hate I hate this program so much. I don't know what else to do. It doesn't make any sense. Why is it not centered? How can this not be straight? Is it straight? It looks like it's, to me, it does look like it's slightly curved or, you know, slanted. You know what? Whatever. I don't give a shit anymore. Can you please get rid of this? Oh my god, why is it refusing to go in the one spot I want it to go? It's right fucking there. Oh my god, what the Jesus Christ, I hate this program so much right now. I'm so fucking... Oh my god, I hate you, I hate you, I fucking hate you. I'm not in the mood. Okay, so here's that. Should hopefully be good. And now it's all fucking weird. And then my taskbar won't fuck off. Why is my computer running like it's actually hemorrhaging right now? My CPU's maxed out. That's really cool. AVG is taking up 10% of my CPU power. Thank you for that. Really love AVG. Oh my god. Oh my god, and now the chamfering is messed up. Why? Because this isn't connected. So we need to extrude that there. Okay. This isn't centered. At this rate, I just want to fucking start over. Probably honestly be faster. How? Mic face width divided by 2. This one is centered from the corner. This one is also centered from the opposite corner. And they're both the same measurement, yet this one is just a little bit too close to the side. Why? Okay, you know what? I honestly don't care anymore. Delete it all. I don't care. Okay, starting over. So we have this mostly done again. Finally have this proper right here. We need to make the cavity for it, which I don't think I have any parameters for. I think I just measured it and went with it. 9mm from the bottom. Bump distance from mic bottom, which will be 9mm. The smaller, the bigger it's gonna be. So then we need to get a new sketch, and here. Create a projection of this face, just get all of the edges. So then we'll do a line from here to the other side. Put that on there. Then I need to figure out how tall they are. Figure it out from the bottom again. Okay, a little past it is 16mm. Bump end distance from bottom is 16mm. I want to double check the other one because I think it may have been a little off. It's right about there. A little underneath it. 9.5. Yeah, because there was a little bit that I was off, so I'll do 9.5. Okay, and after this updates, we can make another line, connect those there, and do this edge, like so. End distance from bottom, okay, pull this to the side there. Then we'll connect these on the edges, that I can cut properly, hopefully. Let's actually just hide the body, because I think it might be messing up the sketch a bit. Did these lines actually get created? I think they did. So then, let's make a line, the distance here. Make another parameter. Minimum clip bar thickness. And I think we wanted it to be at least 3mm. How much is it on here? 3.5. Actually, it's getting closer to 8. I mean, to 4. Let's just make it 4. this is going to be construction. And then from these corners, we need the 45-degree angle to just go to there. And I guess we'll just, yeah, it'll just be 90 because it's offset now. And it's zeroed at that. That, and then we need to close this off like so. So then we have that solid area. Hopefully that's not too awful bad. Actually, let's measure it. 7.6 millimeters is pretty far. I need to shrink this. 3.5. Took away my measurement, of course. 6.6 is still a little long, but oh well. We're going with it. Show the body. We're exited out of the sketch, so I need to extrude these now to this face. Okay, so now we have that. So now we have the main body created. Save it. Okay, so now we just need to add the fancy details for now. I believe it was wall thickness divided by 2. Then we do another one. Is this also wall thickness divided by 2? I don't think so. I mean, it works. Looks decent. We'll go with it. Then we also need to chamfer in. Well, actually, we could probably round in the inside here. Probably make it look a little bit better for how the microphone sits in there. Wall thickness divided by 2, so then it rounds in exactly where it ends on the chamfering. And it looks pretty slick, if I do say so myself. Then we want some rounding here. Okay, there's that. We need rounding. We might not even actually need it, but we're going to put it on here. Clip wall thickness divided by 2, so then that perfectly rounds it. I think we have it recreated again. That didn't take too long. Might even be created better now. Now let me double check this, because if this is the front, buttons are on that side. Then eventually we need to figure out where this circle goes. And we're also hoping that this is just going to work. I really hope this thing works, because I don't want to keep printing these out. Now let's measure it from the bottom, and this is going to have to be where the edge starts. First of all, the diameter, it should be 3.5 millimeters. Yeah, 3.6. So, first things first. Headphone jack diameter. I don't know. I probably didn't spell that right either. Headphone jack diameter, we're going to do 3.6. So then we want to add some tolerance to that for headphone jacks. Or for the actual, male jacks on headphones. I'm going to say add 1.5 millimeters of tolerance onto that headphone jack cavity diameter. So we need the headphone jack diameter plus 1.5 millimeters of tolerance. Hopefully that should work with most headphones. Let me see here. I got some headphones. I got a few different versions of headphones sitting around here. See, now this one has an L connector on it. That might not even work, because what's the depth on this? Almost 4 millimeters, so hopefully it would still work. Probably make the body thinner in general, at least a little bit. And what's the diameter of this? 5.5, so that would have been a little bit too small. I was thinking probably around 2 millimeters, but if I do 2.5, we'll see how that works, though. I think that might be pushing it with how close it gets to the edge here, because it's also not centered, which is real trouble. Okay, so headphone jack from edge from back. Headphone jack edge distance from back is about 4.4. Then edge from bottom, because the bottom's going to be, even the bottom's farther, it's going to be easier to measure. Well, I may stand corrected, but it's not going to be any easier to measure the other one either. Looks like 30 millimeters. 30.7 or 30.8. Headphone jack edge from bottom, but they don't even let you measure the edge, do they? At least not with an actual. It's really frustrating. But there is ways to fix that, actually. So then we need another sketch on this side. We need to project. I mean, this is the total size up top here, so we need the whole thing. Project these 4 walls. Then we need to make a circle the size of the normal headphone jack diameter. Then we need to make lines that are construction lines going in the XY, or whatever, something like that. We need to go with the distance here to here, and that should be from back. Then this one from the bottom. And then, logically, I think I should be able to use this tool, the tangent tool, to make this work. Yes, because now that should be the exact position that we need, putting the edges where it needs to be. Now the problem I'm having is that this is already very close to the edge, like I was saying. We're just gonna do this to face. Look at that, there's not much to work with. So, I bring up the sketch again, and we make another circle around it, and we make this headphone jack cavity diameter. That's gonna be too big. Make that one a sketch. Finish this. Re-extrude this to this face, and it cut into the edge of the wall there. God, why? Why did they have to do this the way they did? So another solution is to make another cutout of sorts after all that work. But then it's that one edge is still going to be a problem because we have a 2.5, which is already a little over exaggerated, but only like by the tiniest bit. So what if it's just 2 millimeters? It still clips into the wall because you only have that little bit right there. That's is that even a 0.5 millimeter? This headphone jack may just have to not be usable, because they put it in a freaking weird spot. Of course, they probably didn't even come close to thinking about this as a possibility in the first place. So, oh well, I guess. So, let's just make a line here for now. With the edges, so we have wall thickness plus, say, 2 millimeters. But then that's gonna make an issue over here. Okay, so we're just gonna have wall thickness then. That would be that total length, width, whatever. Okay, then the verticality of it, should have kept that circle, huh? Because I just want there to be more than enough space. Let's Control Z until we get that circle back. Okay, there's that one. So this one I want to be 2 millimeters away from there. That's not what I pressed 2 and it just ignored it completely. This is parallel with something right now, but it says that it's not actually horizontal, which is horrendous to hear. Oh, what is it doing? Why is it this? Why are you? Oh my god, I fucking hate this program so fucking much. Stop. Just fuck off. Stop existing. Shut up. No. God damn it, I don't fucking want the main body. I want the fucking edge. It always does the opposite of what I want. I don't know how it knows what I want and then does exactly what I don't, but then it always does what I do not want. I could be sitting there making a mistake where it will select the wrong thing, and then I go to select that wrong thing when it's actually what I want, and then it'll do the opposite again. So stupid. Every time. Okay, now it's freaking properly in place. Now, let's get a line going from here, make it a construction line. Let's try and get, so this thing should go to, yeah, that line should go to there. Then we make a line going up, and make a box. Okay, then from here we want those, the 2 more millimeters. Well, we don't, well, yeah, we do need it. Okay, and then 45. Have that go to there. 45. Mine's 90. There's that. Now let's get a line going between here. Measure the line. It's about 4 millimeters. Let's get the distance. 5.5 to 4.5. It looks like it's way longer because I took it down a whole millimeter, so it would need to be 5. Measure here, and it's about 5 millimeters. We'll go with it. Finish sketch. Then we need to extrude. Well, we need to remove these extrusions. Then we need to extrude here and here to base on here. Bam. Okay, so that hopefully should be big enough that it could fit at least some headphones if I really needed it, and hopefully earbuds, because earbuds usually have a much finer jack ending on the protection, the rubber and all that. Okay, we got all that figured out, so this should hopefully be ready to print out for another test, though I have no idea if it's actually going to work or not. But oh well. I've saved it, now let's export it and slice it and get it printed. We're just going to print the whole thing because we got to test this thing, we got to test that thing. I'd like to test the front, but I'd also like to test the back. But if I print the whole thing and this doesn't matter, then it's going to be a problem. Then, well, it's just gonna be a little bit more wasted filament if if this doesn't work anyway. Dang it! Now I'm gonna make a freaking test model. Okay, so we need to copy this model, paste it into the same folder, make this one read only because I'm on the free version, so they're dickheads about how files work. It's the most minor inconvenience thing, but it's so freaking stupid, especially when you're going through their system, because you have to go through their servers, so then it takes forever to do so, to switch things. It's really stupid, but oh well. So now we have this one open. We need to go back into the main sketch. We need to segment off this right here. Just take all of that out. Get out of my goddamn way. Now in the extrusion of the walls, we want to take that one wall off, which then will mess up that extrusion there, but I don't give a shit right now. Now we can save this, and then we can export this. Okay, so now the other model is now re-exported. Now let's get it in here. Okay, there it is. Slice that shit. Okay, it still is able to make this wall. It's even actually probably able to make it a little thinner if we needed it, but I don't know how much thinner I can go without it being too brittle and bad in general. Okay, well, let's send it to the printer and see how it goes. Okay, so, been a little bit since I worked on this, but here is the next prototype, and it is sitting in there basically as perfect as it can be. Right now, my dog was hiding under my bed, and she's coming out right now. Been sitting here for like 20 minutes trying to do some troubleshooting, and now she wants to come out. Never fails. Anyway, this is sitting in for... Oh, are you kidding me? Now I have a phone call. Okay, hopefully I can actually do this now. Okay, so this is fitting just about as good as it can be. There's a little bit of it coming out, but that's just from the natural indenting of, or angle of that's just how the clip sits in general. It's in there basically perfectly. There's the most minimal wobble. The only thing that I noticed that I don't like is how the buttons sit in here. So the buttons that are a little off, you can still press them, but you also can't see the labels, which I didn't think about. I only thought about the buttons themselves, and because of how stable this seems, I'm hoping that I can get away with some smaller, even smaller walls, so that hopefully I can expose the text and maybe give the buttons a little bit of room, because it looks like the buttons are just offset just the tiniest bit from the center, because even though the wall is not pressing any of the buttons, it is right alongside of them. So I don't know exactly how I'm going to measure this stuff, but let's get to work and see what we can do. Turn this light back on. Oh, I had to just restart my computer, so I don't even have Fusion up because the freaking webcam was breaking. Oh! Okay, so I'm gonna take this out of the test thing, and I'm gonna try and do some different measurements here. Now, the text goes to the relative back. I don't know how well you can see this, but it goes to pretty far back on the corner. That's a little annoying. But if I can see it at all, hopefully that will help let me see, what button it actually is, and if I need to ever actually press it. So let's say the gap should be 8.5 millimeters, but it of course is not centered. What the f? This looks all different. I know Fusion just updated, but goddamn, really? Unsupported OS. Product support requires a version of Windows that is supported by Microsoft. I got special treatment and enrolled in another year of security updates, so go fuck yourself. Dumbass bitch, get the fuck out of my way. Device theme matching enabled. Cool, fuck off. Stop. God, I hate Fusion 360. So many little reasons. First things first. What's the point of having the UI be dark if the background is not dark? It's still blinding me. Now I need to remember something about button. Button control width. That has plus fit tolerance times 5. So it's a millimeter extra. Let's take that out and we'll do the 8.5, since it should hopefully have more than enough room then. Enter. So now that should be getting wider. And it also needs to be offset. This camera is being stupid. We need to change the sketch. I believe that should be the sketch 3. Here we go. Because this is centered when it doesn't, it needs to not be now. So we need to look at it like this, because we need to get proper way that we want it to be offset. Okay, so from the front, God, it's so hard to tell this stuff. Let's try 2.5 millimeters from the edge. So we need to delete this one. Then we need from the edge here and from this corner 2.5 millimeters. So then it should have less on this side, more on that side, and it looks like that's about right. It automatically shifted properly. All right. Then I also need to print this and test it out and see how that looks. I think I also should probably just model in the bottom of the system and get the handle going. So let's look at this and see what there is to see. So we need to decide how big we want the handle. 19 millimeters looks pretty good. Let's see what 19 millimeters looks like on here. Put a sketch on the bottom there. Create projection of the bottom there. We need to get the middle points. Okay, that does not look good there. I mean, if it was just the handle, yes, but that's why I'm drawing this circle, is to get to see how I want to try and stick the handle into this. So I don't think we're just gonna stick the entire handle in it, and we also can't have a perfect circle there. We need to have at least one flat side, but I'll probably do two just to be safe. I don't know from a design standpoint what would be more comfortable. If you're having the flat on the sides of the handle or on the front and back, I don't know. I guess I could. It doesn't matter unless if I can make this ambidextrous and have it turn one way or another. Okay, so this already has 4 millimeters of depth. I want at least 2 for strength and, actual wall placement on the bottom here. So maybe 2 extra millimeters for the bottom. Sounds about right. Let's do that. But the question is, how do I want to do this? First of all, let's make a parameter. I don't know if that's how you spell diameter, but that's what I'm going with. 19 millimeters. Then we need to get this line in here somewhere. Let's just go with front and back for the model for now. The line just needs to go and be as long as the circle itself. Then from the center, let's say handle diameter divided by 2. Put that in parentheses. And then what if we divide... We don't want to divide that by 2, I don't think. Let's plus this, copy this. I have to do this how I know how to do it, because I think there's an easier way to simplify this equation, but I don't know exactly what it is. Divided by, it needs to be divided by 3, divided by 2, plus that. That's not what I want. Divided by 3, I think I can get rid of this, and then multiply that by 2, I believe. Because I wanted to get 2/3 of the way out, but it doesn't make it super easy all the time. I think this overhang, because this is how it would be printing, at least looking at it from the back side. This is how it's printing vertically. It would lay on this face. So I don't know if this is still too steep of an overhang. It looks like it might be. Because another way to solve this problem is that if you use if you used like a hexagon or something, but I don't want to use a hexagon. I want it to be mostly rounded. So I'll print it and see what happens. Then we want to paste what I copied from the other one so that it'll be even. So then that should be our handle size there. I don't know if there's gonna be too much flat area for the comfortability of holding it, but oh well. Finish sketch. So the next thing we need to figure out is how we're going to insert this. So since this is the bottom part of how we'll be printing this portion, we need to make these holes relatively small so that they don't sag while printing the main area. So going back into the sketch, let's put a line down here. That's the middle point still. We want to actually delete that. Put a line here. Let's put another line over here. We got the middle points here. These are going to be construction lines. That is not horizontal. So what I'm thinking is like 4 pegs and then 2 on the actual handle. Or I could just put 1 in the center. First of all, handle peg diameter. Should be able to handle 4 millimeters. So we're gonna make the peg diameter 4, and then we'll make it a little bit bigger on here. All right, so this is the center point. Peg diameter. Then we'll do another one. Peg diameter plus fit tolerance. Okay. What's this distance? I wish I could freaking see it. Create derivative. What does that say? 3.167. Jesus, okay. Because we also want to draw those circles out here. Let's make a construction line in between these. Another one over here. This one needs to be measured from the center here at 3.167. I don't think there's something that would be really cool that I think a lot of people want is, I don't know what the right term would be, but derivative, what's it called? Parameters, where you can take a measurement between like some points and then have that become a parameter. But there's a lot of computational power and complexities that can happen from that, I understand. So they have not implemented it as far as I know. But I need to do that number over here as well. Okay, now another circle. Oops, that would not have been correct. Handle diameter plus fit tolerance. Give me that. I'm gonna copy it. And then when we do it over here, just gotta copy it. Then copy it again, but get rid of the fit tolerance. And there we go. Okay, so now I should be able to rotate the handle either vertically or horizontally. So actually I shouldn't, because I only want, let's make it like this, where we make these construction sketches, because we want to use these two for extruding on the handle, and we don't want to use these one. We want to use all four of these for extruding on the body rather than on the handle. Hopefully that makes sense, and hopefully it actually works. So now we should be able to start doing some extruding. So we need 2 extra millimeters here. Make sure you get those. Except we don't want these circles. So we have the 2 millimeters here. Gets added to the bottom. Okay, bring the sketch back. Now we want to extrude these by -2. So that should cut into there, and that should be 4 millimeters deep. Let's get, one thing did not go right, because I did not also select the fit tolerance rims. These ones should have it already. Okay, so there's that. Yeah, pretty sure that's good. So now, before we move on, get rid of the sketch, and let's chamfer the bottom of the entire thing here. Now we can't do it a whole lot due to the overhang. Logically it should be able to print it, but sometimes I don't think it does properly quite as much. Should also make a parameter for it. So let's just say mic holder bottom chamfer. Let's just do 2 millimeters for that. Now let's get it going. It does not like it because of this curve. What if we get rid of the curves? It doesn't like it there either. Huh. Well, that explains why. It's because it's curving in like that. That's stupid. So if we don't, what if we chamfer these but not the inside? Nope, still doesn't like it because it's a fucking bitch. Okay, so that's the back anyway, so it shouldn't make too much of a difference. It's just, this chamfering is just for presentation, but it also does help with hopefully removal off of the build plate. It does not look like it's going at a 45-degree angle. That does look too steep. Distance and angle. Supposedly that's a 45-degree angle. I mean, okay, we'll go with it. So now we have that. Now we can make the handle. We need to get this sketch 6 back. We need to hide the main body. We need the inner sketch here and here. I should have a parameter for the divot, for the peg depth, but I just did it manually because I don't know how much of a pain it's gonna be if I were to adjust it. I think I'm still gonna do it. I'm gonna change it over. Handle peg depth, which is also gonna be 4 millimeters. So on this extrude, we want, crap. That one we just want to keep, no. Okay, I know how we want to do this. So on this extrude, we want -2 millimeters, and that's that. On this one, we want peg depth minus -2. So that should, if we measure, inspect, get the sketch out of here. Here to here, it's 4 millimeters. Okay, because that should ensure that the extrusion accounts for those 2 millimeters, even if we decide to make the depth bigger. That means that the bottom length will get longer, but not too much longer, because we have that -2 that cut into the main body already. Okay, hopefully that should all be logically sound. Now, get rid of that. Extrude here and here. This is gonna be a little weird though too, isn't it? Okay, so we need 2. Nope, that's going the wrong way. So we need the -2. Okay, then we need to extrude this again with handle peg depth -2. Okay, those are joined. All right. Then we need another sketch on the bottoms of these. Then we will project these lines right here. Okay, get rid of sketch 6. Finish this sketch. Then we extrude these. Don't know why it took that circle and not the other one, but oh well. Now we need the length. That's a good question. The longest my my calipers go is 153 millimeters, which is, it looks like way more than enough. I probably don't need that much. What's 100 millimeters look like? 100 millimeters looks pretty decent. You know, you hold it like that. Got a little bit of length on the top and bottom. Maybe let's give it 125. Let's see what that looks like. Then you got even a little bit more length. Sure, let's go with that. Handle length, 125 millimeters. Okay, wait for it to buffer that. Then we extrude this. Handle length, boom. There's the actual handle. Okay, which then joins these two together. Looks like a big ass battery or prod or something. And then if we show this battery, that's what it should all look like. I'm going to chamfer the bottom, make it look a little better, hopefully. Let's actually make a parameter for that too. Handle and chamfering, which I don't know how much it's going to be. Let's try 4, honestly. We're also going to need some chamfering on the ends here just to make it a little bit easier for fitting, but I think I'm only going to do 1 millimeter for that, maybe 2. Let's see here. Yeah, millimeter's fine. 2 millimeters would probably be too much anyway. The only problem with this now is actually printing these. I could probably have a little bit of support right there, and that should hopefully take care of it. So one thing I did not think about when printing those is how they're going to be supported coming straight out if we're printing flat on one of these sides. But yeah, I'll have to use some supports there, only a minimal amount, and hopefully it should work. Let's get the chamfering on the end here. Wonder if rounding would look better. Let's see what the filleting would look like instead. It might look a little better, but the rounding can cause issues with the steepness and such of the angles. Show it to me with the chamfering, especially the chamfering actually goes with the kind of visual style we've been going for here. Okay, so there's that. That looks, I think that looks probably decent. There it is. Hopefully that should be good. Before we print the handle, I want to just print the body and test it out one last time with all the walls. I shouldn't have made the bottom. Let's go back some steps here. Remove the bottom because we don't need it. Actually, did it add anything? Oh yeah, because there's the extra length right here, right there. Okay, save a little bit more filament that way. And we want to test to make sure these buttons are in the right place, this button slot is in the right place, and I want to check and make sure and see if that headphone jack is going to work. So, let's print just this and see what there is to see. Gotta save. Okay, saved. Now, let's export. Just fuck off, I don't have time to fucking update every goddamn time I fucking open this thing. Every time I open Bamboo Studio, it wants a new update. Okay, button and headphone test. There it is. Bam, bam. Slice the plate. Always does the stupid thing where it starts on filament instead of line type, which it's where? There. Okay. Don't think I need to slow it down. In fact, the speed might actually help with those overhangs. So we're gonna print this and see what happens. Okay, so here are the 2 printed pieces. I printed out the test model and it was basically perfect. It might be a little snug, but we'll see. There's some stringing in here. Hopefully that doesn't affect it too awful much. It obviously shouldn't. But yeah, then these come off really easily. There's the supports. Can I just flick those off? No, that's gonna be a little bit more difficult, as I expected. All right, okay. So first things first, we gotta take off these supports to see if this will even have a chance at working. Oops, I accidentally took it off and threw it somewhere. There it is. Okay, so it looks, I don't know if this camera's gonna be able to pick it up, but there's just the tiniest imperfections here. it doesn't look like it should hopefully affect the fit of this. So let's see here. It greatly affected the fit of it, actually. I can't even force it in. So I might have to reprint this part. I don't know which one takes up more filament. I still don't really know which way is better. Looks like side to side is better than front to back. So this almost was perfect. However, I assume because of the supports, it needs quite a bit more tolerance. Another thing I didn't think about was I made this design where they can freely flow into each other, these holes. However, when you do that, it's going to take a lot more glue. The glue is going to spread out into these other slots, and then it's going to be an issue. So I think I'm just going to get rid of the front and back slots and just have the side-to-side slots. Okay, so I've been thinking about how I want to do this. Why is this so quiet? So I'm thinking I want to just reprint this since we want to kind of get rid of these other holes anyway so that we can glue it a bit easier, but this will also allow us to put a lot more fit tolerance on these circles since that's what we really need. So the first thing we need to do is find the proper sketch where this is. That's not it. We need the one before that, which is over here. So we should be able to get rid of, we want them side to side, right? Yes. We should be able to get rid of these two at the top. Then we want more fit tolerance. So then we need to put fit tolerance in parentheses. And I'm thinking I want to multiply it by 3. So we have 0.6 fit tolerance. That's multiplied by 6. I need to multiply it by 3. There we go. Let me just copy that. Paste it into here. Oh no, what have you done? Oh my god. Okay, so they're a bit bigger. Hopefully they're big enough. I was sitting here trying to look and analyze and see, just how big this is, which it's hard to tell how much bigger it is, and it doesn't seem like it's a whole lot. So I'm just going to try it like that and see how it turns out, because these circles should hopefully turn out decently big enough, though they are being printed on the bottom, which can mean that while the main body of the circles are being printed large enough, the very bottom of it may be printed a little too small due to elephant's footing and such like that. But let's export it with these enlarged holes and without the other two, and we'll see how it turns out. So I thought about it, and as a precaution in an effort to save filament, what I'm going to do is I'm going to slice this so that I only have these holes left, and hopefully that it will be a, reasonably rigid object so that it won't be too far off or anything like that. It won't be, false data, but yeah, I'm going to see if I can do that. So let's try and get this done here. Kept the absolute wrong piece in place. That was my phone. I just heard it go off back there. I can't do that shit. Don't worry about it right now. Oh, holy Christ. I did not think about the other pieces. What the fuck is that, dude? Look at it. Should be 6 millimeters off of the plate. Good enough. And to save a little more filament, I'm just going to cut these ends off since we don't need the full length of it. At least I don't think I would. I don't know why I would exactly, but, that's what's happening right now. Why did it put it on its side? That is so fucking stupid. What is wrong with you? That's going to be printed. I could print it in a different direction, but it would not be beneficial to us since we want to know how it would be printed in this orientation anyway. So we're going to slice this thing and we're going to print this itty bitty little bit, and hopefully it should go by quick, though because of the preparation, it's going to take a little longer, about 10 minutes. So that's going to be a little annoying to have to come back to, but oh well. And it's so small that the infill seems to be filling up completely, because the infill is actually at 10%. I mean, it makes sense that it's so small. Alright, we'll print this, and we'll see, hopefully, that it actually will fit on the end of our stick here. Okay, so the little peg thing, test peg thing, fit decently, so I already printed the other piece. Saved us a little bit of time. There's the bottom now, just with the 2 pegs, and ooh, it's kind of snug, but it does fit in. This thing looks kind of stupid as shit, if you ask me. It's kind of weird looking. Some people might like the look of this. I think it looks weird, but it's hopefully going to be functional. Let's test it out and see, I guess. I also don't know if I want to glue this down. For some reason, this can't get all the way down on the surface of the other print. I don't know if it's because something, I don't know if it's sagged outward somehow. That doesn't really make sense to me, but oh well. But it is a decently snug fit, so hopefully I shouldn't even need to glue this, but I can shake it around and it doesn't even fall off, so yeah. Let's try this thing out. Okay, so here is the microphone working. The level is very low on my camera, and the preamp level is very high on here. This microphone is prone to a lot of handling noise, so it can, when you rustle around, it can pick up a lot. It usually can also pick up a lot that's happening around the room with the higher microphone level. I might be able to, if I turn the preamp down, I might be able to try and negate some of that, but it also will raise the noise floor, of course, because the louder the source is, the better. So how does it sound? I mean, that's more of the that's more of, you know, the opinion of the microphone, I guess, but, you know, I don't know how it sounds with me holding and waving it around. Does this do anything? Okay, well, there's a little bit of rattling that I can even hear, so that's not helpful. If I tap on it, I don't know. I don't even know how that sounds. I could monitor it because I did make sure that the the headphone jack was accessible, and I tried it a little bit with a few different microphones and headphones, and it did work. So yeah, hopefully this sounds decent. I'll have to review it after on the recording. But for now, that's all I have to say in this video. So if you enjoyed it or found it useful in any way, please leave a like and consider subscribing. If you want to keep me on this platform and have me keep doing what I do, things like this, please consider subscribing and check out maybe some of the other channels that I have as well. I usually have them linked on the home pages, but maybe I haven't kept up on that. I don't know. Either way, I hope that that this was useful to someone. But for now, I'm going to say bye-bye.